Hey guys, welcome to episode 2 of Behind the Tech, and we are back here again in this lovely library with Ben. This week we have a lot of very interesting topics to talk about and ask you about, actually, Ben. One of the main things that has been the talk of the town this week is BitChat by Jack Dorsey and Grok, an LLM that has went rogue. So for those who don't know, let me just do a quick recap of the news and then we'll get Ben's take on what's happening right now. So Jack Dorsey just announced his new project BitChat, currently in limited beta, where he has created a messaging app that operates on Bluetooth. So instead of on Wi-Fi or on like cellular tower, cellular network, it is through Bluetooth. So we kind of want to dig in a little bit on the technology behind that, as well as Grok recently going rogue, talking all loads of crazy stuff. And I'm going to ask Ben, how did that happen? But first, okay, BitChat. What is this Bluetooth technology messaging? Is this something new that we've never seen before? Or is it just a reiteration of something that's been in the works for a while now?
It's an interesting concept because it's a peer-to-peer swarm mesh network. So it doesn't depend on any large company's assets, right? So I actually designed a swarm network protocol in 2012 that was for like doing things out in like concerts and stuff out in rural fields, and how you could move internet traffic, and it basically would like share the traffic between everybody's cell phones, and did an open call auction on paying people for their internet usage. So you could do high bandwidth video broadcasts amongst a big crowd by paying to rent everybody's local internet connections and dividing your content up in real time. But it didn't get funded, so it didn't happen. But this kind of thing is an interesting hobby of mine. There's also open wireless protocol called LoRaN, which can go to multiple kilometers. That's very interesting. That's very low bandwidth for like sending messages around. So what is the, what's the use case for Dorsey's BitChat system? Seems to be mostly in being able to, like, if you're a group of protesters and you want to have private chats around your protesting group, seems to be a great way of doing that. Having crowds doing something that's everyone's within like 300 to 600 meters of each other.
So I have a question, which I don't know if this is what it will be able to do. In the case of a natural disaster, like maybe a case like a few months ago, we had an earthquake and all cell service was down, internet was also down, and it was hard to communicate with each other because everyone was using the internet, right? So I couldn't call my family, other people couldn't text each other. Would something like BitChat be able to communicate when there's so many people messaging each other?
Well, so BitChat's a interesting idea, but a half-baked protocol. It can't scale. So when you get to a certain crowd density, the problem is that you don't have like a login into it, right? You have a handle that you created on your device that maps to a UUID that's created on your device that nobody had a user registry on. So there's not any way of saying I want to communicate, from me to you directly. As long as we're in the same mesh, any message you send out goes out to everybody you're connected to, which then goes out to everybody they're connected to. So it's geometrical in the amount of traffic that goes on as more and more people get added. Eventually, you will saturate the bandwidth of the Bluetooth protocol. And so there's only really maybe like effectively like 100K bit per second bandwidth. So you're not going to do voice. You're not going to do video. It'd be good for like doing like text messages. But as soon as you hit a certain number of people, it's going to get overwhelmed because of sort of the gossip protocol that it uses is very naive. So it's not bandwidth efficient.
Will they be able to scale that to a level? Because right now, obviously, it's like a...
Not with the protocol as it's designed. However, you could. So if you've heard of the Tor network, so like the Tor network is for doing like encrypted connections on your browser, and talks to another Tor agent, and they have a thing called onion routing. So even though everybody else is routing your packet, nobody knows who the original sender is or who the final destination is onto it until it arrives at the final destination. Then you know you are. And so that's a smarter routing mechanism that I think could be adopted, and then that would vastly reduce the amount of bandwidth growth per user in the system, let it scale out, and actually provide additional security. There's a lot of, think that you're a protest group and you're wanting to go, you're going up against the government, and and you don't want the government to see, who you're talking to or what you're saying. You can do that if everybody kind of started together and shared their addresses ahead of time. And it kind of works like the old IRC chat system, right? So you can have chat rooms or you can have one-on-one conversations. But anybody in the chat room can see all the chat room messages. But how do you prevent other people from getting into the chat room? If any one of those people shares the password to get into the chat room, they can enter in. They can listen to see what everyone is saying. So it's not it doesn't have strong operational security. And I think that most users who would use these devices and would use this protocol aren't very OPSEC aware themselves. And so, you want to be careful how you use this thing. The other use cases are, you've got a natural disaster, so the cell towers around. As long as you're not in a super dense area, it could be something that's useful. It doesn't require you to have walkie-talkies.
Yeah.
The other use case scenario that's been mentioned is this would be a way for you to transfer Bitcoin between people.
I was about to ask that.
Without any other infrastructure, because you can exchange your UTXO transactions. Now you still somebody still needs to present those to the Bitcoin network and get that mined, so it'll be in a block. But you could conduct not high value transactions peer to peer very easily and be like a local Lightning Network kind of model. So I can do all that. I think what's mostly unique about it is that unlike all the different things like LoRaN and some other swarm protocols, everyone's got the device that they need. Bluetooth comes on all your phones. Doesn't need anything more than that. We recently built an application for a security company that monitors the other devices that are around you, monitors all of the wireless forms of communication, Bluetooth, Wi-Fi, GSM, even near-field communication stuff. So a more obvious protocol to use would be Wi-Fi and do peer-to-peer Wi-Fi. But as it turns out, the Apple, in its infinite wisdom, they hate developers, and we hate you back. They have continually closed access to the low-level protocols on iOS, and so iOS no longer allows you to see who are the other Wi-Fi devices that are around you to talk to them in a peer-to-peer manner. Cut it off. You can still do it on Android. So Bluetooth is the last peer-to-peer protocol that exists on everyone's devices that you can use, and I have a guess that's a good reason why Dorsey picked that one.
Okay, that's very interesting, because I think, my question would be, right, because this is a new project that he's developing, and it kind of goes along with his new persona as like this Bitcoin evangelist. Mm-hmm. Do you think
and freedom evangelist as well, which is part of the whole Bitcoin concept.
Yeah. So you think as the project develops, do you think it will scale to something much larger, like a messaging for everyone, or is it going to probably stay as something to use for really doomsday situation, protest situation? We need to send Bitcoin. This is the only way we can.
Yeah, well, I mean, it depends on what he and his community decides to do with it, right? Mm-hmm. But if it's, I believe, now I have not actually played with this. I don't have an account on it or whatever. But I believe the intention is for this to be just a completely open source thing. Mm-hmm. So you absolutely could extend the protocol, right? So the very first obvious thing is to have gateway nodes, which would be like some nodes that are connected to the internet that are now using their internet connection to store and forward messages. And so now this would immediately be like a global thing. If you ever used an Apple iTag, the Apple iTags, mm-hmm. right? It's working with a similar kind of mechanism. It's broadcasting out chirps. Is it using I forget if it's using Bluetooth or it's using its own frequency range. I'm forgetting. But it depends on other Apple devices being in the vicinity, and then they're forwarding things out through gateways, and so Apple can track the universe. I think it's most insane that people are using Apple's products and trusting Apple for this from a security perspective. But you could easily extend BitChat to work in that kind of a similar manner, which would vastly increase the range of it and the number of users could do it. You would have to eliminate the complete gossip protocol, and you have to do something a little bit smarter in terms of routing. But again, these are all things that I've done, so I'm sure Jack knows how to do this, and his developers know how to do this. And so like a version 2 of the protocol would be necessary to scale out. But it's absolutely possible to do.
So in this episode, we really want to dig more into this security side, and also dig into what are the potential threats or potential interesting facts about cybersecurity that most people always kind of look over, and we should dig into that this episode. But before that, just quickly with the Grok news. So recently, Grok has gone crazy and gone rogue, people say, creating these anti-Semitic or crazy conversations online, answering on behalf of the @Grok handle. So I just want to ask you, because we did talk about LLMs last week and hallucinations. Is this something along that lines of hallucinations, or why does Grok know how to say these things?
So this is entirely the issue with LLMs that I was talking about last time. LLMs are just a token predictor. When they see a stream of text, they're going to start continuing that text with what are the most likely things to be said. Okay, so what is the most likely thing to be said? Well, it all depends on your training data. What was Grok trained on? Grok was trained on all the Twitter past data, and probably a lot of internet stuff. And so when you look at what anybody can write, so Grok doesn't have any ability to determine whether it's true or not. It just sees whatever it sees the most gets the higher bump. And was it Himmler who said that if you repeat a lie long enough, many times, it becomes a truth? That is literally what happens when you're training an LLM. So there's more anti-Semitic content than there is content that explicitly speaks against anti-Semitic content. And why is that? Is that because the universe that Twitter is more anti-Semitic than it is, pro-Israel or even neutral? No, it's because this kind of outrageous crap is just nonsense, and nobody even needs to really speak back to it very often for a human to understand this is crazy nonsense. But for an LLM, it's just the frequency of the terms that it hits. It's going to do that. This is inherent in all LLMs. If you train on data that contains this kind of frequency bias, not a logical bias, a frequency bias, it's going to adopt that frequency bias as truth. And the only way to get around that is then you have to do some sort of human feedback training where people go in, like a teacher to repeatedly. Did you see Clockwork Orange at the end of Clockwork Orange, where they hold the guy's eyes open and play these terrible things while he's listening to classical music that he used to love, and now it's trained him to get ill whenever classical music is trained. That's what you got to do to your LLM to break it of these biases. You have to override the bias by forcibly training content that will diminish the frequency of the content you want to get rid of. And that's the reason why LLMs are so woke, as we say it.
Yeah, because
they can be woke or they can be Nazis. Comes from the same reason.
So last week, because we were talking about how nowadays all these companies are using LLMs and coining it as like the next super intelligence, because they're now able to, to, some of them would pass the Turing test in small iterations.
Sure.
But obviously now that we can see that, it's definitely not, it's just kind of like a parrot repeating what it's trained on. Exactly how we were speaking about yesterday.
It's our immortal parrot.
Yeah.
It's exactly what it is.
So yeah, obviously now, as we see more cracks within this new wave, I guess, of LLMs being the new hottest thing, whether there's going to have to be a kind of new emergence of the next thing, like we were talking about last week, the exponential AI. How can LLMs improve and become better? Like, do we have to incorporate other systems with the LLM in order to do this?
Right. So exponential is kind of, exponential is your system develops some question that it wants to resolve. It wants to try something, do a test something. It does this, and then it measures the outcome to see whether that was a good or a bad thing, whether that hit the desired that it wants. So that's a very different thing than
also it wouldn't be something
training on tokens. Until you can get reasoning into an AI of some sort, you can't just train on gobs of streaming written data to discover truth. This is why I think you look at the valuations of all these AI companies. You look at the valuation that it's done for NVIDIA, right, and the size of these things, and you look at what their potential income streams are. There's no way they're ever going to be able to pay back those valuations. There's going to be a lot of these companies that go to zero, whatever. And what I believe is that companies are going to, you need LLMs that are good at communicating, content between humans and computers, right? Because that's what they're good at. But when you're looking at LLMs for facts, you're in really, really big trouble. You're going to need to train those facts. You're going to need to have LLMs that are specialized towards your domain, right? And again, use a hybrid ontology-based system like what we do at Biggest Lab, and then you can really optimize an LLM for your domain experience and with your own data, and not what just is all the random stuff that was out on the internet, because then you're going to get these kind of crazy hallucinations where it's calling for the deaths of Jews and stuff like that. Which and who knows what else, right? Where it's scraping stuff. So I think these companies that are training on all data, their LLMs are going to be worth a lot less than companies who specialize training for neutral content, does not contain things that you don't want it to have, and is then improved upon by either RAG systems or ontology-based systems for domain expertise that are using knowledge bases that aren't 100% contained in the LLM. Because the cost of training these LLMs is so expensive, right? It's so crazy expensive. And then LLMs are always improving. So if you've gone in and you've improved this one LLM with your company's data, and then Grok 4 comes out, now you got to go through that training thing again. So the LLM isn't really the place to put your data. The LLM is the place where you want it to speak about your data and talk about it after you've got a knowledge base that reveals what you want to the LLM, and that sets the context, right? It's all about, just like in human interactions, it's all about context, right? What you say, context is very important. Well, people are completely missing that by the way they're treating LLMs and AIs today. They just think that they can just absorb everything and it's going to come out with the truth. And we know that's not the case, right? Frequency, repeating things over and over does not make it any more true. And LLMs have no ability to determine otherwise.
Okay, we're going to go into our security section and security segment now, where we kind of talk to you a little bit because you have a security background, right? Maybe you share a little bit more about what projects you've worked on within that security background, and then maybe I'll ask you about, some frequently asked questions from people about cybersecurity, what is actually a threat, and what can people actually do about it. So first of all, your experience.
Okay. It's always going to be long. There's no short version of this. So I was a security and encryption guy, and crypto guy. So crypto meant encryption back in the 80s and 90s. So I've been doing that since pretty early days. Just hacking on things because it was an interesting geek thing to do. Now I'm not an encryption math guy. So there's two types of people in the security space, right, or in the encryption space. There are the math people who are really into the elegant math solutions, and then there's the engineers who implement them and make it work. I'm on the engineering side. I'm not the purest math guy, but I understand structurally how most of the functions work. I'm just not up on the math theory so well. So I used to do things like making encrypted messages, writing files in an encrypted manner. I was CTO of a small startup company in Atlanta that we had a product that cleaned up your internet tracks for your web browser, and you can imagine the types of clients that would get. So most of it is like covering your porn tracks and stuff like this. But there was also businesses and all this kind of stuff. And we were in negotiations with a firm that was I think it was EDS, one of Ross Perot's old companies, and they were looking for an encryption technology to adopt. And I remember the guy talked to me and was saying, like, we like you guys because you're not associated with the porn industry, because all the competition in that space was associated with the porn industry, and they were wanting to like recommend somebody. So like I'm really at the verge of like inking this deal with this guy, and one of our main funders was a guy named John Malcolm, who was a pretty heavy duty guy in the Republican Party. Mm-hmm. He was a prosecuting attorney guy. And when the second Bush got elected in the office, I found out how close he was because they appointed him Deputy Attorney General of the United States under John Ashcroft. And they put him in charge of terrorism and technology stuff. So he had to divest himself of the company. So he had to sell his shares in our company. So we lost our primary investor, replaced it with somebody else. And the president of the company, in a fit of panic, I guess, he hired, what is this porn star's name? Oh my God. There's some major male porn star guy.
Just say you hired a porn star. He
paid him $500 to do a promotion for our Cover Your Internet Track software so he could build up some more sales.
Oh gosh.
And so he got some more $45 sales and lost probably a $500,000 contract, and then I resigned the next day. So there's one of my security anecdotes. Yeah. So it's a wild, wild world in the security space, especially in the 80s, 90s. So one of the companies that I worked for, I was a consultant, was Internet Security Systems out of Atlanta. They were the premier world-class, really tracking things down. My specialty was exploits for instant messaging applications. So like BitChat is an instant messaging application, right? But if you had AOL's, what was AOL's chat? AIM, yeah. If you had a Windows AIM client, a certain version of it, and you were talking to me, I could control your whole computer. There's so many exploits in these systems. Yahoo Messenger and all that kind of stuff. ICQ, I think, was one of them. And so I was one who helped create the detectors for when these exploits are coming through your network, and I put this in the intrusion detection systems of there. But at the time, the government really didn't have a capacity for this. First of all, nobody who was this kind of hacker could ever pass a security test. Most of them, were taking various drugs to keep awake at night. Do long stuff. So they didn't have anybody. They couldn't hire anybody because they wouldn't pass the security test. I don't know. I guess they must have relaxed that more or less these days. But there was like around 2000, 2001, like India and Pakistan were like threatening a fight like what we've had recently, and it looked like they might get to a hot war. But the crypto fight was already on, and they were completely attacking each other's infrastructure and stuff. And so like FBI people would come to ISS's office to figure out what was going on. Like that's how, that's what I say, they were the top dogs. They were the top dogs. Like they knew what was going on. And so they got sold to IBM for like $400 or $600 million a few years later. So that was an interesting space. But
so within like cybersecurity, I think most people don't really know what is considered a threat, a cyber threat, or a cybersecurity threat. Can you give examples? Because you say in messaging, right? What is a potential threat that it could have?
Right. Well, so those are the exploit that I did. That's the sexy stuff that everyone writes about. Oh, this software had a 0-day exploit, which means like nothing you can do about it. If this thing is connected to the internet, like Windows, what's the email system that Windows Exchange, Microsoft Exchange, email system, had exploits into it. Like if somebody there were some exploits, somebody sent you a file to your email, you didn't even necessarily have to open up the email and it would like get into your system. These kind of really bad ones. But that is like less than 1% of the actual, when they happen, but it's like, what can you do as a regular user? Most of this stuff is social engineering, kind of things. They get into they have to get past the person, right? And the person is always the weakest link. So it's things like good password procedures and what we call operational security. OPSEC is the term. So humans are naturally trusting, and if you say anything that sounds like you're familiar with that individual's situation, they figure you're on their team, and then they'll tell you all kinds of stuff. So that social engineering is the main thing that goes on. So people need to be trained on not being so trusting with running software, and of course the people who get exploited are old people who aren't computer literate and stuff like that all the time, right? You hear these call centers that are mostly running out of India or Africa that claim to be computer support, and they get you to run some software in the crypto space on Telegram chat channels. Yeah. I see in all these crypto rooms somebody coming in saying, "Hey, I'm an investor and I'm looking to invest in crypto projects," because all of us have a crypto project or 6, in our back pocket. And then they try to get you to chat with them, and you can't chat through the normal protocol, so they ask you to install their chat software. Well, then they just own your system, and they're going to look for your keys, and they're going to move all your crypto off of it. I see this happen like multiple times a day. Yeah. And there's enough people that are falling for it that this happens. So you really got to don't install stuff off the internet that you don't know. Don't know what else to say about that.
Okay, so since you've been working in Thailand, what are some potential businesses within security that you've worked on, and also what are some threats you see that a lot of companies in Thailand always neglect?
Okay, one product that I built through that previous company that lost was securely deleting magnetic media after it was decommissioned, right? So companies would spend a lot of money, putting your computers behind firewalls and protected information and all this kind of stuff. Like hospitals are good ones, psychiatric centers, all kinds of super. I did some stuff in Atlanta for a 400-bed hospital, and wow, the data that was going on there, talking about what people's parents did to their children and all this kind of stuff is all in this system, right? And super secure, really limited access. But now, 2 years later, it's time to decommission this computer and replace it with a new one. Send the computer out the door and sell it for basic money. And I recovered so many hard drives that had all of that kind of data on it still. So not securely wiping out. And you can't just delete stuff. You have to overwrite it. And so I wrote some special software that did like this Gutman encoding, 34 cycles over your thing, so like not even an electron microscope can recover it, kind of deal. So, you have to be very careful about what content you have and where it goes, especially after your computers go away, right? Because you've spent all this money in your security budget, and then computer's out the door with the hard drive. You sold it for somebody, for $50, and you just gave away millions of dollars worth of your private content. That's one of the ways where I see a lot of very valuable content go out the door.
Yeah. And you were before we started recording this episode, we were talking a little bit about like what we're going to talk about, and you also mentioned working in Singapore and within the Singapore startup scene, having a lot of issues within this as well. Could you explain?
Sure. Yeah. So I can give some more anecdotes. So developers. So when you're writing software, there's kind of two aspects of writing software. There's the functional aspect, which is these are the features that we want to give the users. And then there's the non-functional aspect, which is how do we keep the lights on? How do we make it accessible to people? How do we make sure that only the right users get in and not the wrong users? So starting in 2009, we were very much involved in the startup scene, especially in Singapore, because that was the only place really where you could raise funds as an early stage company. Like there was VC companies in Bangkok, but their funding requirements were more strict than an American bank giving loans. So that's not a VC firm, right? So it was nonsense. But we would have companies come to us and say, hey, look, we've built this software and it's been running for the last 6 months, but something weird's going on. We can't extend it anymore. Technical debt was going on. And I remember we had one company in particular that had this MySQL database with all their customer data. And they brought it into us and we evaluated it, and they said, there's strange things going on with our database. And we looked at it real quick, say, wait, this is your live system, this is your production system, this isn't like your development system? Yeah. They had deployed their MySQL database with all the ports open onto the internet with all the default passwords for MySQL. So everybody in the world who knew their IP address could come in and do anything they wanted to their database. And were, by the way. So it was amazing that it was still running. And so they were asking us can you fix this? No, you can't fix this. You have to stop. You have to take this offline. You have to shut down this business right now, right away, because you don't know what data is good or bad and who has it. And this is before there was reporting requirements. But so you need people who understand the non-functional requirements, right? How to keep the system from falling over when you get a lot of users. We have customers. We have one customer, the American Geophysics Union in the United States. They're in DC. All of the earth sciences papers get released through their fall meetings. So they have like tens of thousands of people. And before they hired us, every year in the middle of the big meeting, everyone would log on at the same time, and their system would fall over. Even though the vendor swears they did performance testing, because they didn't know how to do performance testing that actually simulated the full browser experience. So we have some technology that we had developed, improvements of some open source stuff and some other neat tech that we have, where with just a couple of machines, we can simulate 300,000 users hitting the system at once. So they've been with us since 2009, and every year we evaluate their system, and every year we knock over their system and find a reason why they're not going to be able to meet their stuff. And so they've been a customer for ours since then. So if you need capacity and performance testing, the non-functional side of things, we have the ability to do that in a rather unique way. And then they've referred us to other clients. So we have kind of a practice for doing that. It is a security thing, because it's also making sure that there's not a way of exploiting system. But more importantly, it's the non-functional, making sure your system can scale, make sure it hits the performance expectations that your users have, so they have a good experience on this. And we're also able to advise the clients on how to improve it and find out where their bottlenecks are, because we can real-time monitor all their systems while our tests are running and dial in things for them. So that's a interesting thing that we deal with. That's a lot of fun, actually. It's cool to knock over people's systems and have them pay you to do it. So that's the white hat hacker thing that you were asking about.
Now that you kind of mentioned white hat hackers, black hat hackers, for a lot of people, when you hear about cybersecurity, you first think about hackers, right? Guys in hoods, and then they're like trying to break into a system and then steal some information. So you're just explaining how, as a white hat hacker, you can get jobs from companies who don't want these people to hack into their system and steal their information. So can you tell us a little bit about the different sides to this hacking? So when you're a white hat hacker and you're doing it on purpose, hacking into the system on purpose to see where the vulnerabilities are, what are you looking for? And if you were a black hat hacker, like a black hat hacker, what would the difference be?
Right. All right. Well, so obviously
is it red team, blue team as well? Is that?
That's an orthogonal aspect of it, but I could talk about that too. So the white hat hacker, as you can imagine, is like the company has invited you to come do this. And usually there's some contract involved where you say what you will do. But the main thing is that you got to promise like not to damage their system, change things, reveal stuff. But yeah, it's a engagement. Now, the truth of the matter is that most good white hat hackers were at some point a black or gray hat hacker, because that's how they, how are you going to, if you haven't been there, seen it, done it, how are you going to know how it's done to prevent it? And that gets into like kind of the red team, blue team stuff. So red team, blue team is like, blue team is like it's your side, it's the customer side. Red team is the attacker side. So as a white hat hacker engagement, you might do a red blue team thing. So it's usually the customer with you as a consultant acting as the blue team, setting up the defenses and all this, and then a red team, which is usually you as a consultant or your partners, trying their best to exploit it, right? So that's what that aspect is. Gray hat is kind of like we're in this quasi-legal thing. Maybe we don't fully have permission, but we're also maybe not violating any laws necessarily, or maybe we're on laws that maybe people don't want to prosecute. And of course the laws change. So black hat hackers are people who will actually. Gray's typically the main thing is that there was a hacker's ethic code. I actually wrote one in 1989 and published it.
Oh.
The main core tenets of it was that because back in the day, the whole idea was if you're doing this, if you're breaking into a system, you should like tell the people that they've got this exploit and let them know. And you should also promise never to damage their system or hurt the environment or change the data or alter something for customers. But so I had hacker friends in my little town of Fort Smith, Arkansas. There was a hacker group, and a lot, and also related to hackers was the concept of phreaking, PH.
What is that?
Phreaking with the PH for the F. That's phone hacking. So before we had personal computers and stuff, we used to hack the phone system. You may have heard of Captain Crunch, who was I believe he was a blind guy.
Captain Crunch, like the cereal?
Because there was a whistle. So the entire phone system worked on a set of dual modulated tones. And there was a whistle that came as a toy in a Captain Crunch box that happened to blow the perfect 2600 hertz thing. So you may have heard of a magazine called 2600. That was a hackers group magazine. It's because of this frequency was one of the control frequencies for the entire US phone system and ultimately the world phone system. Okay. And so you could blow this in to your phone and it would put you in a different mode. And now you could do neat things like you could pretend to that your phone was now off the hook. Back on the hook, but your conversation still goes, so you could get like free long distance.
Oh.
Yeah, there was.
That's a real hack.
Yeah. So this is in my high school days. we had an almost international group where so a lot of things. So back in the days, long distance was extremely expensive, and so you had MCI and Sprint, and you had these phone cards where you put in like 6 digits, and then it would let you have discount long distance. Well, so people would do what's called war dialing, and I have a very good friend of mine from Fort Smith. Whenever we go to the bowling alley, you would see this guy, we called him Rusty, in the phone booth at the bowling alley, and he's just typing in, trying random 6-digit codes until you get numbers, and you would just collect these numbers, and then you could sell the numbers. And so until the phone company detected it, because somebody get this really large bill, you would have free long distance for like a month. And so you could sell the long distance codes. So that was a black hacking kind of thing on the phone system. There was a company called Alliance Teleconferencing that was that used to let you do international conference calling. That was a huge expensive thing. It was $1 per minute per person plus the long distance charges for everybody who was dialing in for this. But it was how you set up teleconferences without having huge teleconference codes on your system. People I know would create conferences would be just a bunch of hacker guys, and everyone had their own handles, what their names was. Nobody used their real names, and this is how you would exchange information about people and stuff. And we whoops, cut out the wee thing. Yeah. I remember there was one New Year's Eve. Yeah. So also people who are phone freaks were also often happen to be in ham radio and be interested in radio. So one of our guys was a ham radio operator. And he had this giant book which listed the registry of every radio station on planet Earth. It's this big-ass book.
Wow.
And it had their phone numbers, all the registration details for every single country. And we had this goal for one New Year's Eve that for every time zone around the world for 24 hours, we would call up a radio station and get ourselves on the air, talking about, hey, we're a hacker group and we've done this and this kind of crap, and announce our team on there. And so we did this. But then when you're waiting for Australia, there's several time zones where like there's nothing there. There's no radio stations, right? So we're waiting. And so we say, okay, well, let's just dial some random digits. There's like probably like 12 of us on this conference call that we're doing this, and so we were getting on radio stations. The DJs loved us.
Oh yeah.
They just ate this crap up. And we dialed these random country code, city code, last 4 digits, and we got some girl in Melbourne, Australia. Actually, twin 17-year-old girls, as we found out later. And what was cool about Australia, this is the 80s, and Australian rules football was on ESPN2, and Australian Crocodile Dundee was a thing. So it was like, and Men at Work from Australia were happening, and all this. So it was like, wow, okay. So we talk to these girls, and they're hearing, there's like 12 guys talking to them. So, how did you get our number? It turns out everybody in Australia has secret phone numbers. Nobody has listed numbers. In the U.S., you have to pay for that privilege.
So there are no yellow pages.
Yeah, there was no white pages. But apparently not, like a very thin book. And so, how did you get our number? And I said, well, we're this group, and we got this thing, and we're going to call the cops, and be our guest. We didn't care. And so, well, we'll prove it to you. Give us your friend's phone number, and we'll add them to this conference call. So they gave us one of their friends' phone numbers, who was this girl named Diana Alivska.
Oh, you got going to put that out there.
It's cool. I hope she finds this. She'll love it. She'll love it. And she became a pen pal for my best friend afterwards.
Really?
And they started trading off. They would send cassette tapes back and forth between Australia and Fort Smith, Arkansas, recording things that were on the local radio and just talking to each other and stuff like this.
It became a love story?
No. But it was a really cool thing that came out of this. We got connected to Australia through phone freaking. And we would add their friends onto the conference, and they just thought it was the greatest thing. So we were on that for like 4 hours. This is the kind of stuff that
I've never knew that this phrase or this phone freaking thing.
Yeah, phone freaking was a thing.
Was a thing.
Yeah.
Wow.
Wozniak, Steve Wozniak of Apple, like he used to build these blue boxes and stuff to do this, and they actually called the Vatican pretending to be who's our Secretary of State, Henry Kissinger, trying to talk to the Pope, and they got through to like a lead cardinal.
Oh my God.
And all this. There was another exploit that we detected. Shreveport, Louisiana information had a flaw. It's long since gone. It's been gone for several decades. But they had a flaw. If you called information for Shreveport, Louisiana, and you just didn't say anything, the operator, operator information, then they hung up. You got their dial tone, which meant you're an information operator. And we could get all the information we wanted, and we could call out to other phone things, and they would think that we're an information operator. And so we could get into anything and anybody by doing that. We were information operators from that. And it was all you had to do was just wait for the lady to hang up and wait to hear their dial tone, and now you dial out. You are just like you were sitting in that information operator's console on their phone line. So that was
you had a wild
thing.
Teenage years.
So, statute of limitation long gone. And also the rules against that were not so. The worst they could do is get you for the long distance fees and stuff like that. Although there is some things.
Okay.
I did have a friend. So CompuServe, before the internet was a public thing, you had these dial-up services, and CompuServe was a big one. And one of the things that hackers shared were, if they captured somebody's CompuServe credentials, so you could log in and be on CompuServe, that was another asset you could sell. And a friend of mine used to do dumpster diving behind the mall, and back then the credit card was, you get the little carbon paper for the credit card things, and you had the person's credit card.
Oh.
And people used to just throw those into the trash at the back of the retail stores. Bad OPSEC.
Oh.
So this is what dumpster diving was called. Literally, they would jump in the dumpster and try to find where the thrown away carbons were for these credit card transactions, and then you could sign up for a CompuServe account on that. And my friend, who is now dead, unfortunately, he died a few years ago. He got caught, and he went to prison for a few years.
For dumpster diving?
It's for the
credit card.
It's for the credit card. So I never ever charged anything on anybody's credit card. I just played with the phone systems and stuff. Okay. He's dead. He was a super cool guy who got caught. And when he was on CompuServe, he met this So he was like only a couple years older than me. So he must have been like 18, 19 years old. And he met this lady from Canada who was like in her 40s and had a Corvette and came down to meet him.
Interesting.
Okay, anyway, I could go on for hours for this. I think we're going too far.
Okay, I think we have last question.
But this is operational security, right? Is I guess it was kind of a long story long. It's not always, there are some exploit things that are technical, but most of the stuff first started with somebody doing something that broke operational security, throwing away those credit card things into the dumpster. People are doing that kind of stuff all the time. If you let your hard drive go out, you lose a USB drive on the street.
Yeah.
Right? People recover that, right? So all my computers, 100% of my drives are encrypted. So that there's no way, even if you get hold of the physical device, that anybody who's not a nation state is going to be able to get into that drive, even if it gets into somebody else's hands. People need to adopt these kind of practices.
How do you encrypt your own personal devices?
Almost every operating system has this as a feature when you format your drive, to format it as an encrypted drive, which means when the computer starts up and you want to start using that drive, you have to type in a password for that drive, and then it just becomes a regular drive, and that's it. It's not very hard anymore. It used to be a really hard thing to do, but yeah, every time I install a new Linux thing on my laptop, encrypted drive even on the boot, and there you go, and very little overhead now. So it's crazy not to always have everything encrypted. Okay. So BitChat, all the messages are encrypted. Yeah. But also with BitChat, it's not so hard to impersonate somebody else. So like, if you've never chatted with me before, and I see that you're in this chat room with this other person, I could pretend to be that other person because you haven't exchanged private keys yet, and then you might think that I'm that person. So there's some operational security holes in the current BitChat protocol that jumped out at me. That will definitely need to be addressed if this thing gets any more wider adoption. But it's a very initial version of it, right? Yeah. So I'm not condemning it, but it's definitely half baked. Yeah. In terms of capacity and in terms of security. Okay. Going back to our original discussion.
Our last question to kind of wrap up the security section of the podcast is, what forms of threats do you see coming in the future? Like going into this new digital age with AI, agentic agents, MCPs, and all this stuff.
So yeah, you hit on really where I think the biggest. So we're going to start seeing a lot of exploits of what people call AI bots, right? So there's this protocol called MCP, which is basically how do you expose your computing resources in a manner that LLMs can now use them. Right, LLMs can now orchestrate them. People may have heard of a concept called, if I can think of the concept, microservices, right? And what microservices are, so when you're building software, you can like build this one big massive piece of software, or you can build lots of specialized components that then interoperate to each other to orchestrate and have emergent behavior that is your real application. Well, this latter concept, microservices, has been taking on a lot. But these microservices are always hosted inside your own private environment and stuff. And what I am seeing is that a lot of these AI agents are basically people putting like this MCP protocol wrapper around what they used to have as a microservice, like
can you explain,
like an employee database.
So Can you explain to me in the most simple way, what is an MCP?
So MCP stands for Model Context Protocol. What it is, it's a way for a piece of software that's connected to the internet to expose itself so that an LLM can actually use it. So if you tell an LLM to use this MCP service to help answer the question, the LLM can ask the MCP, what are your capabilities? And any MCP service can do one or more of three things. The first thing is to do a task. Right, so it's something that changes state, that does some behavior, like fill in a form or create a new record or something like that. The second thing that they can do is they can provide access to resources. Resources are typically databases, like a knowledge base, so you can like do a request for some data. And the third thing that an MCP service can provide are are some prompt templates, which is basically they're basically hints to the LLM on how to use the service itself. So if you just replace these parameters in this template and submit this prompt to the MCP service, this prompt will correctly use the MCP service in the way the designer expected. So it's a way of exposing compute resources to an LLM so that you can do things. You can make these bots smart, and you can have LLM-based AIs actually perform tasks for you, right? Now, how are these things getting implemented? The thing is, these things are going to be exploited like crazy, because when you look at the definition of the protocol and it talks about security, it says, oh, well, since the protocol is over HTTPS, which is what all web services are over, just use OAuth as your security. Security done. Well, no. OAuth is just a way of confirming that you are a user who has that you are a user, that they know. It doesn't express the rights that you have to use certain pieces of data in the system. So if you've got your entire database exposed as an MCP service and you're just using OAuth, you have access to the whole database. You don't have any what we call fine-grained permission to certain subsets of the database. And what I'm seeing a lot of MCP services are starting off as somebody's existing microservice that was sitting behind their private environment that's behind firewalls and protection, and now they're putting an MCP protocol around it and then sticking it on the internet, because it has to be accessible to the internet to get the full value of it, most of them. And so all of the authorization, so there's two parts of security, right? Authentication is proving you are who you are, and authorization is saying, now that we know who you are, what rights do you have to perform these functions or access this certain data? So there's auth N for authentication, auth Z for authorization. And they've got no authorization capability whatsoever, which means now the MCP agent implementers are going to have to code that manually, which again, that's a non-functional thing, which is different than functional stuff. And most programmers suck at that. So it's going to be stuff that can be exploited. So without really good secure standards for this, I expect that we're going to see a lot of MCP bots and agents get exploited. And this is actually an area that we are addressing. So our Big Vault system actually is composed of a bunch of MCP services and talks to and exposes knowledge bases that are MCP services. And we have an identity service called Big ID that handles the OAuth authentication, but also allows you to, using RESTful protocols or other database protocols, put in finely grained permissions as to who can access what aspects of the system and who can't. So if you were to expose your MCP service connected through our Big ID service, it would make it very, very simple for your developers to just declare certain permissions and rights and not have to write code for it. And our Big ID service would automatically implement and enforce those protections for you. But lacking capabilities like that, if people haven't really thought through the non-functional security aspects of their AI agents, we're going to see tons of exploit opportunities going on. And a lot of companies are going to be losing a lot of private data, or having people be able to do tasks inside their internal systems that they didn't expect to be able to happen. So that's the AI agent aspect. The other aspect, of course, is people who are just, you're now using LLMs for everything. Yeah. Everybody in your company is using LLMs for everything. And you've got all this secure data that these users are supposed to be protecting, that your company paid a lot of money for, has a lot of value to this data. You don't want it to get exploited. It's all going out to these LLMs and these LLM companies, and you think that they're really not going to use your data to train their system, despite what they claim. We know these big companies have all lied to us before about stuff. Look at Facebook, how they were, talking about advertiser data and like this. And then even if the big companies realize, hey, we got legal jeopardy, so we're not going to do this, their employees don't care, right? There's a lot of employees in these companies that have access to your content that are then going to exploit it and sell it to other people. And so controlling what kind of content gets out into these LLMs is something that most companies have no ability to even consider. We recently were invited to do a tender for a very large government agency here in Thailand. And in the request for proposal that was presented to us, it was for an AI implementation system. And this is super highly private data that this thing controls. So private that they wouldn't give us any single example of their actual content for us to do the bid against, which is amazing. But in their RFP, it specified that we should use this particular service to publish our bots. And that service would expose 100% of all their data to the whole world.
Yeah.
So their entire RFP that they actually wrote and paid somebody to create this thing for them would violate the law if we were to fulfill this. So we had to point that out to them. By the way, this aspect of your RFP will violate the Computer Crime Act of Thailand if we fulfill this. So we're going to have to decline.
So there is obvious lack of understanding, lack of knowledge about how to protect their information, their server, and any new program that they create.
Yeah, because people are just treating this AI as some kind of magic stuff and not realizing that it's like having a gun. It's a very powerful tool. If you use responsibly, used irresponsibly, it can do great damage. And that's what's going on with these companies doing AI stuff, and it's around the world. I mean, we're just so this exploiting and doing particular security consulting for AI bots and agents, I expect to be something that's currently in demand. I was at a security conference a few months ago. Every single security company is now claiming they're an AI company. When I was working with our ed tech company, and a couple years ago, I went to the ed tech conference in Bali with my client. Every single ed tech company was an AI company. Yeah. And they're all LLM based, and they're all hype. We are the no hype AI company, and I'm the no hype AI guy. It's a great tool. It's fantastic, right? But you got to be realistic, and you got to be careful. And unless you're engaging somebody who understands these kind of problems and has this kind of experience, they're going to lead you down the wrong way. Like this government agency, they paid somebody to write that RFP who supposedly knew what they were doing.
Yeah, obviously had no
that
idea.
That RFP cannot be legally executed.
Yeah.
And or ethically executed for that matter for the type of data that this was exposing. So these are the kind of security things that are clear and present dangers. Let's say.
Awesome. Well, that is it for our episode today on security. Thank you so much, Ben, for really digging in and explaining the tech behind all of these things. I think a lot of us are still quite unaware of the dangers that new technology like AI, especially how fast it's developing in these past few months. Like AI changes every few weeks, few months, it feels.
Absolutely.
So it's something that we definitely need to keep up to date with. And if you or your business are looking to find an expert who can actually look into your services and see what exploitation or what problems there may be there, then please contact Ben. We'll put up the contacts up right now on the screen. And yeah, thank you so much. We'll see you guys next episode.